Question 4. A circle of radius 3 centimeters passes through all the vertices of a regular hexagon. Determine the area of the circle that lies outside the hexagon. That is question 4 of the KCSE 2024 paper 1. So the best way to go about this is to try to put this one into an illustration. You know, they say that a picture carries 1,000 words, but in mathematics an illustration can be able to represent even 1,000 statements. Therefore, let's go ahead and try to put this one into an illustration so that we are able to visualize well the details that we are given in the question, so that then we are able to solve it. So we can see that we have been told about a circle, so we can try to plot a circle, not a perfect circle but just a sketch. Assume we have a circle like that one. We are told a circle of radius 3 centimeters passes through all the vertices of a regular hexagon. Another figure here, that is a hexagon. We are supposed to ask ourselves, what is a hexagon? A hexagon is a 6-sided figure. Therefore, we should have a 6-sided figure whose vertices are touching the circumference of this circle. So let's try to find how we can be able to plot that. So that is a 6-sided figure whose vertices are touching the circle. So we can have our first vertex from there, our second one there, our third vertex there, that is the third one. We can have our fourth one there, our fifth one there, and finally we need to have the last one. We can have it somewhere there. So that is our hexagon. We can see that it have got 1, 2, 3, 4, 5, 6. Those are 6 vertices. And let's read again the question. A circle of radius 3 centimeters passes through all the vertices. Yeah, according to our illustration, the circle is passing through all the vertices of the hexagon. But then we are told, determine the area of the circle that lies outside the hexagon. Therefore, the question is interested in this part that is outside the hexagon. Let's see if we can be able to maybe color it or maybe have it colored like that. Yeah. So the question is interested in this part. That is the part of the hexagon, or rather the part of the circle that is outside the hexagon. Therefore, the part that is outside the hexagon, or this part that is revolving around here. I think this one, it's, yeah, this part that is around there. Let's just shade it a bit. Yeah, I'm just doing this so that you're able to visualize that. So that's the part that we are interested in calculating. You know, if the moment that we've drawn this, the question has become a little bit easier for us, because now we are able to visualize what is required of us. But then we start with what we've been given. Let's assume that this one is the center of the circle, and this is a point from the circumference to the radius of the circle, which is actually 3 centimeters there. That is 3 centimeters. Then that would imply that every part and every length that comes from this part, that is the center, to the vertex of the hexagon should be 3 centimeters. All these length here is 3 centimeters. All this should be 3 centimeters like that. So we are supposed to find the area of this part. So the best way to go about this is to find the entire area, that is the area of the circle. We find the area of the circle. Then once we are able to calculate that, we go back here and then we minus the area of the hexagon, this one, because if we minus this one from the area of the circle, we are going to remain with the shaded part. Therefore, we put that one into writing. That is area of the circle minus the area of the hexagon. We have that right there. So how do you find the area of the circle? The area of the circle is simply pi r squared. I believe you can write that down. That is pi r squared. Pi r squared. And then we have minus area of the hexagon. How can we be able to find the area of the hexagon? I think it's a bit easier for us to calculate the area of one triangle, and then we multiply by 6 because we have got 6 triangles. This is the first one, the second one, the third one, the fourth one, the fifth one, and the sixth one. But then how do we calculate the area of one triangle? We know that this length is 3 centimeters and this one is 3 centimeters. Therefore we can use the part, or rather the formula, a half AB sine theta, and then we know that we are supposed to multiply by 6. But how do we calculate the theta? The theta, if you look this very keenly, we've got 6 equal sides. The first one, the second angle is there, the third angle is there, the fourth angle is there, the fifth angle is there, and the sixth angle is there. Therefore we do 360 divided by 6 to get the value of angle theta, which is 60 degrees. Therefore I believe we've got everything. Yeah, it's like a meal. Whenever you've got all the ingredients that you need, then you can go ahead and cook your food. And that is exactly what we are doing. We have pi. We know that pi is equals to 22/7 multiplied by the radius is 3 multiplied by 3. Then we have got a minus a half. Our a is this length from here to here, that is 3, and b is length from here to here, that is 3 again. Therefore it's times 3 times 3 multiplied by sine 60, which is the theta, multiplied by 6. I believe we can use our calculators to work out this. That is 22/7 times 3 times 3. That should give us 28.2857. We write it down, 2857. Then we put here a minus. This one again you can use a calculator to find out this. That is a half multiplied by 3 times 3 multiplied by sine 60 multiplied by 6, and that is going to give you 23.3827. Finally we can minus this one, minus 23.3827, which is supposed to give us 4.903. This one is in 4 significant figures, 1, 2, 3, 4. 4 significant figures, and now remember to put the value for the unit. We were told that this one was in centimeters, therefore this one is 4.903 centimeters. If you forget to put the units, then you are likely to be penalized the answer mark, because you are always supposed to state the units for such cases. And that is the actual solution for that question.
Visit our website now, KCSEMathematics.co.ke, to ignite your passion and excellence in mathematics.